Hello everyone. Today we are going to begin our discussion on advanced game theory. Now, before actually getting into the advanced part, as I've written it down, let us have a brief recap of what we have actually studied in game theory. Now, if you remember in the basics of game theory that you have studied, it was basically an idea of players devising strategies in order to maximize their payoffs, right? So if I just write down in one line, it is essentially known as a strategic interaction between the players, and that is what we call it as the non-cooperative game theory. It is essentially non-cooperative because players don't mutually they don't decide on one another's opinion. There is no cooperation as such between the players in framing of strategies. It is a rational player making strategies for himself or herself in order to get the maximum possible payoff. So that is why it is known as the non-cooperative game theory, as I have written it down for you. So now in this advanced course, what we are going to deal with is what we call it as the cooperative game theory. Now, what essentially is a cooperative game theory is, let me first go over what I have written it down for you. That players have an incentive to cooperate to obtain the maximum possible social benefit. That means over here that players of the society, or if you take any set of players as a whole, they have an incentive to cooperate because they know that cooperation will bring greater social benefit. Now, obviously, the social benefit term is a very generic term over here. It might be in terms of social benefit, maybe in terms of profit, it might be in terms of revenue, it might be in terms of utility, it might be in terms of production, it can be anything. So it's a very generic term in the sense which I'm using. So the main intuitive idea here is that the essence of cooperation comes from the fact that people in society know that if they cooperate and work together, then they will be able to get the maximum possible benefit. This is what I'll call it as a cooperative aspect or cooperative gaming. Now, after you have cooperated and have achieved the maximum possible benefit, now comes the more crucial or critical question, that how will you split the resources of the society between the players such that it is agreeable to all groups of the society. That means, if I just put it simply, so after the total output has been produced, now this has to be distributed amongst the players, right, who have cooperated in this production of the joint maximum possible output. So now the question is that after you have obtained the maximum possible output, in what way can you split this outcome between the players such that it is agreeable to all groups of the society? Note that over here one crucial thing, that I am not writing that it has to be agreeable to all players. I'm not writing players, I'm writing groups. Now, what do I mean by groups over here is that, now suppose you can consider, let's say you have a society of n individuals, and I'm talking of cooperative game theory, remember that. So essentially I'm talking of players having incentive to cooperate with one another. Now, obviously, you can understand that when I mean cooperation, then more the cooperation between the players, the greater will be the social possible output. So, larger the number of players who cooperate, the more is better. But essentially, this need not always happen. It might be possible that a society of n players, maybe 3 players or 4 players, maybe form groups of 2 and cooperating. So that is why this term groups. I'll just go into details of why I'm writing groups over here. So essentially, as you can see, this is the non-cooperative set of game theory when it comes to split the resources. If having obtained the maximum output, now the question is how you're going to split it. So naturally, if you give some, you want to give something extra to one of the society, you didn't give something less to the other. So that's where non-cooperation comes in. Everyone wants to get a higher share of the output that has been generated by joint cooperation. So this is the non-cooperative aspect that I'm talking about. So essentially, the cooperative game theory has two aspects. One is the cooperative aspect that people have incentive to come together and cooperate, and the non-cooperative aspect which arises out of the issue of setting outcome in the place. Now, in the entire idea of cooperative game theory, the second one is the crucial point, because that leads us to understand how can separate, what can be base methods of actually distributing the ultimate output between the players who have been part of this coalition or cooperative structure. Okay. So before actually getting to the analysis of the second part, is the most crucial, let us introduce some of the notations that I'm going to use throughout. Okay, so let me just put the next heading over here, which is the notations that we are going to need for having a study of the cooperative game theory. Notations. So the first notation is very simple. It is the set of players that I am talking about, which will be denoted by capital N, and the players will be denoted as A1, A2, AN. So AI belonging to N is a player. This is the formal definition. Number one. Now, before actually going into the second part, let me just have one more notation in hand, which is the definition of a coalition. What essentially is coalition mean? Now, coalition essentially can be understood as something. It is the possible subsets of players that can be formed from the total number of players. That can be formed from the total number of players. Total number of players. Now this might look a little bit difficult to understand, but it's not really that much. So let's take an example that will simplify the things a lot. Suppose I take a society consisting of 3 players, A1, A2, A3. Then what can be the possible subsets that we can think of? It can be, let's say, what are the possible subsets of N? It can be player A1 alone, player A2 alone, player A3 alone, right? They don't want to cooperate with someone else, they want to work independently. It might be possible that player 1 and player 2 decide to cooperate, so this is another subset. Player 1 and player 3 decide to cooperate, this is another subset. Player 2 and player 3 decide to cooperate, this is another subset. And all the players decide to cooperate, this is also another subset. And just for completeness, I also mentioned the empty set, which is 5. So essentially you can understand that I am also writing all possible subsets. So if I take a set of this, it is essentially the power set. So all these possible subsets is defined as a coalition in game theory terms. What does it mean? Let me take an example, or let me illustrate with one of the things that I have written down. If you consider this one, let's say, that means player A1 in bracket. That means over here, so all these are possible coalitions. So if you have a 3-player game, then you can have 8 possible coalitions that can exist in the society. So if I take the first one, what does it mean? That player A1 forms a separate coalition. He doesn't want to cooperate with other players in the society, he just wants to work independently. So that is why it is known as a coalition. Similarly, if I just take this example of this one, let's say A1, A3, what does it mean? That players A1, A3 together want to cooperate, but they don't want to cooperate with other players. That means players A1 and A3 decide to work together and form a separate coalition. That means players A1, A3 form a separate coalition. Separate coalition. This is what it essentially means. Now, if we understand that, let me just go up to the basic question that I was asking over here. That how will you split the resources between the players such that it is acceptable to all the groups of the society? Now, in this example, as you can understand, where we have 3 players originally in the society, it is possible that often all the 3 players do not wish to cooperate. It is possible that A1, A2 decide to cooperate, leaving A3 aside, or A2, A1 deciding to cooperate, leaving A3 aside. Things like that can happen. So it has to be acceptable not only to the individual players but to all possible groups. So essentially the term groups over here that I have written basically refers to coalition that I am mentioning right now. It has to be acceptable to all possible coalition. Let me just rub it out. There is not enough space over here. So I'll just mention it below over here if I just rub it out. So this is essentially all possible coalitions that we are talking about. So it has to be acceptable to all possible coalitions in the society. Now, why is this so? So to understand this, let me bring you to the third notation over here, which is known as a. So let me just first go into the second notation. Let me just formally define a coalition. So a coalition, therefore, is defined as any subset of the set of players. Okay, we will denote it by the notation S, which is obviously a subset of N, and S will be not equals to phi, empty set. Now, to understand that why it has to be agreeable to all possible groups or coalitions, let us get to the second definition over in this context, which is the worth of a coalition. Worth of a coalition. What do you mean by worth? Now let me take an example, otherwise it might become a little complicated to visualize. Suppose I say that okay, there is a three-player society that we have mentioned above, and I'm talking of, let's say, a particular coalition where A1 and A2 decide to work together independently. They decide to cooperate, but not with the rest of the society, but only with themselves. So now tell me that if they work independently, if they work together, sorry, if I'm just rewriting it, if they work together, then what is the value of output? Value of output produced is V of A1, A2. So this is basically how we denote it, the worth of a coalition. That means if two or three, any subset of players come together, then what is the total possible benefit that they can generate? That is essentially what we call it as the worth of the coalition, which is denoted by V of A1, A2. Hence, in general, if I want to denote the worth of any coalition, any general arbitrary coalition, any coalition S, which will be obviously a subset of N, and S is not equals to phi, will be simply V of S. Okay, so this is the second one. Now comes the third one in this context, which is known as the payoff vector. Now, one thing to keep in mind is that we are trying to look at a setup where people are trying to cooperate, and we are trying to find out then what can be the conditions under which they will want to cooperate. So the most important condition is that when the splitting is agreeable, if the split of the final output that has been proposed as a solution is agreeable to all possible groups, then everyone will want to cooperate together in the society and form a overall coalition, right? So before actually coming to over here, so that is the context in which I am going to define a payoff vector. That if all the people in the society come together and produce the maximum possible output, then how are you saying output? Payoff vector. Take care. So before actually getting into the notation, let me just make note of two things. A payoff vector is always defined. A payoff vector is always defined with respect to all players. Why? Because we assume that the grand coalition forms. That the grand coalition forms. Now, if you are still unsure of what a grand coalition is, let me just write down. Just coming back to this example of three players. A society consisting of three players, n of A1, A2, A3. Then, if you have a subset S as, let's say, only A1 or a subset S consisting only of A2 or a subset S consisting only of A3, then these are essentially known as the Singleton Coalitions, one player coalitions. They don't want to cooperate with any other player, they want to work independently. And if you have S equals to all the players in the society together, that means it is N basically, then this is what we call it as the grand coalition. That means in some sense we can say that there is complete cooperation. You can say this because all the players in the society are agreeing to cooperate. So we can say that this is just an informal way of understanding it. There is no such term used in game theory literature. So just I mention it, we can say that there is complete cooperation. That's it. So obviously, now how do you define the payoff vector? Now we are assuming that if the grand coalition forms, then what is the split that you're going to propose? So therefore, a payoff vector, let me just write it out first, I think that will be more convenient. A payoff vector is defined as X, which is, if I take this example, it is a 3-component vector. X of A1, X of A3, X of A2, X of A3. That means, what do I mean? What is X of A1? How much of the how much payoff are you giving to player A1? What is X of A2? How much of payoff you are giving to player A2? And similarly, XA3 is the amount of payoff that is being given to player A3. So essentially, you can understand that here a payoff vector is something where you specify the payoff of each player that he or she would get if he decides to cooperate and form a grand coalition. So the number of players, if there are 3 or n, whatever it is, so in general, if you have a n player structure, then what will be X? It will be a n component vector, X of A1, X of A2, dot 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 dot, X of AN. So you have to specify the payoff of each player in the society under the grand coalition. So this is essentially the payoff that we are considering. Okay. So now having understood, having got the definition of 3 things, that is, first of all, what is a coalition, what is worth of a coalition, and what is a payoff vector. Now let me just have a look at this example and let us just have a look at it in a more exhaustive manner. So let me just write this once more. A1, A2, A3. What are the possible subsets? Singleton players first. Now this I think is very easy for you to write down. It's just like forming of normal subsets that you have done in maths. A1, A2, A2, A3, A1, A3, A1, A2, A3, and obviously for completeness it is 5. What is the worth of each of these coalitions? So the worth of the coalitions will be you just add a V in front. V of A1 if player 1 works independently, V of A2, V of A3, V of A1 A2, V of A2 A3, V of A1 A3, V of A1 A2 A3, and which is often denoted as V of n, and finally you have V of phi, which is equals to 0, obviously, because this is essentially by assumption or normalization. But if you don't have any players in the coalition, then what can be its worth? It's nothing. So that's why we take it as V of phi, which is equals to 0. So let me just repeat once more that what essentially is V of A2, A3? That if A2 and A3 only decide to cooperate separately, then what is the what that they will be producing out of this coalition that they have decided to form? So if A2 and A3 only decide to cooperate and not with the rest of the society, then what is the output that they will produce? That is what is denoted by V of A2 and A3. Now, let me just go over one particular situation. Let us take a particular case for you to understand this. What is the payoff vector under grand coalition? X, which consists of this thing. And if I take a particular subset as, I take S as A2, A3. Correct? If S works independently, that means they do not care about the rest of the society, they just decide to cooperate between themselves and just work independently. If X works independently, then what will we have? What will be the benefit that will be produced? V of A2, A3, right? And if S decides to join the grand coalition, then what is the total what that they will be generating together? Player A2 will be getting X of A2 and player A3 will be getting X of A3, right? So A2 and A3 together will be getting this much amount. So you can understand that if X A2 plus X A3, that means under grand coalition, what they earn together is anyway lesser than V of A2 A3, then these two players together will not want to join the grand coalition, want to join the grand coalition, right? And by definition, you understand that when is a grand coalition formed? When all the players agree to join, right? So if these two players together don't want to join a grand coalition, then can the grand coalition form? No. So as a result of which, what we'll say is that this particular coalition or this particular subset is actually blocking the grand coalition. It is not allowing for an overall cooperation that we are trying to look at. So hence we say that this coalition S blocks the grand coalition. This is the term that we use. Blocks the grand coalition. Okay, just keep a note of this. That means these two players together don't want to participate, because if they participate, the amount of benefit that they will generate is less than what they would have got independently. So why will they have a grand coalition? So that is why we say that S blocks the grand coalition, and hence the grand coalition cannot form. Okay. Cannot form. Now, this actually shows that why have I written this earlier? That in this cooperative game theory structure, we are trying to look at how do you split the resources of the society between the players such that it is acceptable to all groups and not only single players. Because 2 or 3 players, which is a subset of the total number of players in society, might observe that, okay, if we work independently, we are producing more. Then why will we cooperate and form a grand coalition? So it has, if you want to have a complete cooperation and all the players cooperating together to form the maximum possible benefit that the society can get, then the split of the ultimate resources that you are offering has to be agreeable to all groups in the society, right? So this has to be satisfied. So this is a very important condition. If the equilibrium division of resources that you are proposing is not agreeable to even one particular subset out of so many possible. So you can understand that that's a very simple example that there are 8 possible questions. So if I go on using number of coalition, so so many number of coalition possibility that one particular coalition says that they are depending on the coalition, then that particular coalition will block and coalition will not be performed. So now the basic comes down is to have a idea of how can we have a equilibrium of resources. This is the idea that we are going to talk of. So let me just reframe the second point that we have written. So this is a fundamental question that we wish to answer throughout the structure. That how can we let me just not mention the word split, I have already used it. How can we have, just a moment. Okay, so coming back. So how can we have an equilibrium division of resources of the society such that it is agreeable to all possible groups, or in bracket these groups are what we call as coalitions in the society. So essentially we want to find out that what can be the solution concepts that can give us this equilibrium division. So in the literature we have two broad concepts that have been proposed for this kind of a cooperative game structure. The first one is known as the core of a game, which was suggested by Gillies in his 1959 paper, and the second one is Shapley value, which was proposed by Shapley in 1953. So we will take up both these concepts one by one in our next video. Thank you.